And finally, the third type of the output is compound-specific PDF output. So on the screen is the example of such output. If this output is selected, the user will generate a new separate PDF file for every chemical of the training and or the test set, depending on the tasks that have been selected. So this can generate a lot of new files and can take up a lot of space. But if it is selected, this is the type of output that is generated, and it consists again of the information about the data set and the information about every single target chemical, the prediction of the chemical. In this case, this is a regression endpoint, so the prediction is some specific value. And in this case, this is not a real data set, this is just some fake data set, and it is used simply to show the format of the compound-specific PDF output. The ADM value of the target is also printed, and then the structure of the target chemical, as well as structures of all chemicals from the local group that have been used during the prediction. Below each chemical from the local group, the value for that chemical of the endpoint is printed, as well as the fingerprint similarities between that specific chemical and the chemical that is the target. And of course, these similarities are used when calculating the ADM. So this type of output can be used to further assess the predictions and to assess either the reliability or to simply visualize the chemicals that have been used in the procedure. So those were the three output formats available within the IQSAR software. And I would just like to emphasize again that this was one example of output files, and the specific format and various sections might differ depending on the endpoint type that is being considered, and of course whether it is the training or the test set. But the main structure is the one that we looked at. So now let's continue to the tutorial. So we looked at different outputs, and now we will discuss the differences in the advanced mode. And as I mentioned previously, this mode is intended for researchers specific to the QSAR field that are familiar with various specific terms. As you can see, the structure is very similar to the basic mode, with the main difference being the settings section of the user interface. And these sections allows user to modify some specific parameters of the QSAR procedure. The first thing is mask canonicalization, which is an option to canonicalize each smile in both the training and or the test set in accordance to the CDK guidelines. Then the second part is selecting the number of compounds for the local model. The default value is 30, and this can be modified either to a different value or to a range of values between 10 and 100. Then the fingerprint cutoff for both fingerprint types can be changed from their default values, and this will affect, of course, the selection of chemicals for the local models. And finally, since now the binary classification endpoint type is selected, another option is changing the cutoff for prediction of any class. The default value is 4, which means that the majority of predictions from machine learning methods needs to be for one of the two classes. However, user has the option to change this, but then will be prompted to input the class for which the modification will apply. And again, to point out here, as we saw in the output files, this can actually be analyzed regardless of the initial selection. So even if the initial selection is 4, which is the default value, a user can visualize how the change in this cutoff will affect the performance measures. However, it can also be changed initially in the settings section of the advanced mode, as is shown here. And finally, probably the main aspect of the advanced mode that user might want to consider is an additional output type, which is exporting the analysis as a new model. So this is available for any endpoint type if the only task selected is to cross-validate the training set. So only one task cross-validating the training set can be selected to have the option of exporting the analysis as a new model. And if this is selected, exporting the new model, then additional file will be created in the output folder after the calculation is completed. And this file will allow user to either use this model in the future, as well as to share it with other researchers, because anybody will be able to use the model that was built from that user submitted training set. So let's look in more detail how exporting the new model and then using it further looks like. So, as I mentioned, when the job is completed, additional file will be created in the output folder, where all the output files are stored, and it will be this type of R workspace file with the extension of .rdata. So this is the file for the new model that was built in this occasion. And to use this model in the future, the user needs to exit the software and then move this file from the output folder, which is the default location where it will be stored, into the endpoints folder in the same directory where AIQSAR was downloaded and unpacked. So the file needs to be moved to the endpoints folder, and then from that point onwards, it will be available as a new endpoint in the drop-down menu next time AIQSAR software is opened. In the same way, this file can be shared with anybody, and if the new user has AIQSAR downloaded and unpacked, they can put the new file into the endpoints folder, and it will again be available for use in any AIQSAR software. The idea behind this is to have the file stored in the output folder, and then if user is satisfied with the performance of the new model and with statistics, then this model can be moved to endpoints and be used from that point onwards. And this is the end of the tutorial. For this work, I would like to acknowledge the unit of computational toxicology, which is part of the Negri Institute in Milan, as well as Laboratory for Chemoinformatics at Chemijski Institute in Ljubljana, Slovenia, and my mentors Emilio Benfenati and Marijana Novic, as well as the in3 consortium and the Marie Curie network that funded this project. I hope you found this tutorial interesting. Feel free to contact me if there are any questions, and thank you for your attention.